We have yet another no line reference question. So we're going to use the chronology rule to try to understand where we should read in the passage. However, this is one you might also skim because they're clearly asking for this GL person, and so that's something that we could easily skim for. But let's get good habits. The chronology rule also works, and that means we're going to look at surrounding questions that do have line references to help us understand where to read, because the questions are supposed to be in order. So 30 tells us to look at 64 to 75. And 32 doesn't tell us anything. It's another no line reference question. So the line reference here is we're going to have to go to the end. And since 30 is a big one, we actually probably want to go to 64 and not 75 because sometimes the line references do overlap. So I would want to go with this number as my starting point. So look at, that's a lot of text, right? That's a lot of stuff to read. So kind of like in the previous question, we want to narrow our focus and try as best we can, narrow your focus, try as best we can to know what we're looking for as we read this. Rather than just read it and try to understand it all and then go to the question, I want to know when I find the thing I'm supposed to find. So the question is very specific here about what we're looking for. GL differed from Oleson's other test subjects in terms of whatever. So differed from other subjects. We're trying to compare GL to the other subjects. Anything that sounds like it's doing that is worth underlining, worth noting, whatever it may be. So let's start reading. To address the question, Oleson's group sought out a patient known as GL who had an unusual nerve defect. Okay, so she's unusual. That seems like a comparison. More than 2 decades earlier, she had developed numbness across many parts of her body. After taking penicillin to treat a cough and fever, testing showed that she had lost responsiveness to pressure, and a nerve biopsy confirmed that GL's quick conducting fibers were gone, resulting in an inability to sense any pokes, prods, and pinpricks below her nose, but she could still sense warmth, suggesting that her slow conducting myelinated fibers were intact. This is a lot about GL, but notice it's not actually saying anything about his other test subjects. Maybe I end up coming back to this if I can't find an answer, but on first read, this doesn't seem to be making the comparison that I need. It's very generally saying she's unusual, but it's not saying anything about his test subjects. So we'll see. That doesn't sound good. Upon recruiting GL, Oleson tested her by brushing her arm gently at the speed of between 2 to 10 centimeters per second. She had more trouble distinguishing the direction or pressure of the brush than most subjects. Again, there it is. Comparing her to the subject. She had more trouble distinguishing the brushes. So I might not even want to focus on what she actually is different with here. I just want to focus on the fact that they're saying she's different. This is a line I might come back to once I look at the choices and start sorting through the science. So let's keep going. But she reported a feeling of pleasant sensation. When the researchers tried brushing her palm, where CT fibers are not found, she felt nothing. Okay. Oleson used functional MRI studies to examine which areas of the brain lit up when GL's arm was gently brushed to activate CT fibers. In normal subjects, both the somatosensory and insular cortices were activated, but only the insular cortex, which processes emotion, was active when researchers brushed GL's arm. So, again, they're making a comparison, GL versus normal subjects. This solidified the notion that CT fibers convey a more emotional quality of touch rather than the conscious aspect that helps us describe what we are seeing. CT fibers, it seems, specifically provide pleasurable sensations. Okay, these two spots right here seem to be the ones to focus on. So let's go to the choices, and again, I want to better understand what the choices say so that I can bring that into the lines. I don't want to understand all these lines. It's a lot of stuff, a lot of science like somatosensory and insular cortices. I don't want to have to understand that if I can avoid it, but the choices will tell me what to care about. So let's look at those choices. So why are they different? The number of cortices activated in the brain during gentle brushing. I remember reading about that. In normal subjects, both the cortices are activated, but only the insular cortex was active when researchers brushed GL's arm. So 2 versus 1. That seems right. I got to read everything. But it's good that I just found pretty clear matches between these ideas in the lines and in the choice. What else is different? The physical dimensions of the somatosensory cortex. Well, I'm not going to forget it. They talked about that word. Yeah. But what does it mean to talk about the physical dimensions? Narrow your focus to that part of the choice. Are they saying that her somatosensory cortex is smaller or larger? No, they're not telling us the number of inches the cortex is. We never get the physical dimensions. We talk about whether or not it's activated, but that's a different thing than saying its size. So here we go. Narrowing our focus, the science part doesn't matter. It's this other thing that turns out it matters. C, the intensity of nerve signals required to activate the insular cortex. Well, definitely says that her insular cortex is activated, but it never talks about how intense the signals were. It's saying that they're gently brushing her arm. It's not saying they're brushing it harder for her than they had to for the other people. They're not making that kind of comparison. They're saying that when they did the same thing to her arm as they did to the normal people, a different thing happened, right? GL only had the one cortex, normal people had two, but it had nothing to do with how hard they were rubbing her arm. Different things. So again, narrowing our focus, we realize the science part checks out, but the actual result of the experiment is different. The thing that they're measuring is not what's being said in the choice. And D, the effect of MRI scanning on the basic function of brain cortices. Well, no. The MRI is the thing that measures the function. It doesn't affect it. So it's not saying that she reacted to the MRI differently. It's just they put them both in MRIs to see what would happen. This is the way that they see. It's like a microscope, right? It's focusing, it's letting them see something they wouldn't otherwise see. It's not affecting the cortices. It's measuring the cortices. So no, that doesn't work. And even if I wasn't sure, I would say that A is better because it much more like says that in those lines. D, I'm kind of like trying to interpret things and I'm confused and I'm making some assumptions. I don't want to do that. If the lines say what they need to say, that is always the better option. And here they basically say it. Normal people have two cortices, GL has one. That's the difference. And notice there were other lines right here that we didn't even need to know. We didn't even need to go back to. And that's why I don't need to bother understanding every single thing the first time I read it, because sometimes it doesn't matter. I'm glad I pointed that part out, but I didn't end up going back to it because the choices didn't direct me back to it. So we are trying to read as little as possible so that we don't have to deal with all the complicated science. And if that's the kind of stuff that intimidates you, don't worry, because most of the time it doesn't matter. Focus yourself on the stuff that you know. Odds are good that that's all you'll need anyway.